Hi, I'm Justin, and in this video I'm going to be talking a little bit about the Active Circuits lab. So to begin with, we're going to talk about the concept of gain. So gain is your output over your input. Now there are lots of different kinds of gain. You can have mechanical gain through like a lever, or you can have what we'll be looking at in this lab like a electrical gain, and in our case voltage. So if we want to look at some system of gains. So for example, if we have some voltage and we put it through some element with a gain G1, we get V2 after that. And then we have some other element with a gain of G2, and then after that we're at voltage V3. So V2, because our gain is the ratio of the output to the input, we can say that V2 is the gain of this element times the voltage you put into it. Similarly, V3 is the gain of this element times the voltage in. Now if we want to know what the overall gain of this series is, so because we just know that gain is output over in, we can say the total gain is V3 over V1. So using these equations we have here, we already know that V3 is G2 times V2. And then if we rearrange this to get V1 by itself, we can see that that is V2 over G1. Now the voltages will cancel. And because this is 1 over G1, it ends up being G2 times G1. So if you have elements with gains and they are in series, you have gains in series, they multiply together to get their overall gain. Okay, so one of the big things we're going to be looking at in this lab are op amps. So op amps let us do a few things. Now an op amp shows up in a circuit like this. They're triangles, they have an output, and they have two inputs. The minus sign is called the inverting input, and the plus sign is called the non-inverting input. And then they don't show it on circuit diagrams, but every op amp requires power for it to work. So it's got to have supplied power that's not coming through the inputs. It's got to have an external power for it to operate. And that is how the op amp is generating its output. So an op amp can never output more than its positive supply or less than its negative supply. That's an important thing to know. So an ideal op amp they force the voltage at the inputs to be the same. So whatever the voltage is at this input ends up being the voltage at this input. And then no current flows between the inputs. So that means that ideally, inside of this, there is an infinite resistance. So that leads to a couple of useful things. So for op amps, we have three main kinds of op amps, or three main ways of wiring them up in a circuit. So the simplest one is called a voltage follower or a follower circuit. So for that, we have our basic op amp. We have some voltage coming into the non-inverting input, and then we have the inverting input connected to the output. So that means we have some voltage VI going here. The op amp forces that to be the voltage at the other input, and since that's connected to the output, that's what we have at the output of the op amp. So for a voltage follower, the gain is 1 from one side of the op amp to the other. So you may wonder, what's the point of this then? So whatever we get in is just what we get out. But because no current flows through here, and ideally you have an infinite resistance, we can use this to get the voltage out of a voltage divider without loading the circuit. So for example, we had our basic voltage divider like we looked at last week. So we have two resistors, and we called the voltage drop across R2 V out. And we saw that if we try to measure this voltage with a multimeter, we actually put another resistor, that's the resistance of the multimeter, in parallel here. And if R2 and that resistance are similar in magnitude, we can drastically change what that voltage drop is. But since our op amp has an infinite resistance in its ideal form, if we use a follower circuit here to get this voltage, we don't change this at all because we're essentially putting an infinite resistance over here. We get no extra current. We don't change this resistance at all, because if we think about that as an R equivalent thing, we're putting 1 over infinity. So it's 0. So we don't change that equivalent resistance. It still just is R2. So that's the use for a follower circuit. We can get a voltage drop without loading the resistor. So another way of wiring up an op amp in a circuit is an inverting op amp. So an inverting op amp looks like this. So we've got two resistors here. We're going to call this one R1 and this one R2. And then we'll call the output V out. So I'm not going to go through the math on this, but if you say that since this is at 0 volts, this spot has to be 0 volts, so we get no current, you can find that V out must be minus VI times R2 over R1. And if we think about that in terms of gain, which would again be out over in, so V out over VI, that is minus R2 over R1. So it's called an inverting op amp because we change the sign of the voltage. And we know that it does that because we're going into the inverting input. And that's why they call it the inverting input. So the gain is going to be related to these two resistors, whatever their relationship is. So these circuits are typically used to boost voltages, but you also have to notice that we change the sign when we do that. So usually they're used in pairs so that you end up back at the same original sign voltage you were at. So we have inverting op amps. We can also have non-inverting. So for a non-inverting op amp, we're going into the non-inverting input. And we again have two resistors. It's R2 and R1, and this is going to ground. So again, we'll call whatever we're sending into that op amp VI, we'll call its output VO. And if we went through the math, we would see that VO is VI times 1 plus R2 over R1. So again, if we looked at the gain, that is now 1 plus R2 over R1. So similar to the inverting op amp, but now we don't change the sign because we're going to the non-inverting input. And also notice that our gain can never be less than 1. And essentially, if we counted this resistor to be infinite, so it's an open circuit, and that resistor to be nothing, we end up with just a follower circuit with a gain of 1. So we've got the three main types of op amps in electrical circuits. We've got followers, we've got inverting op amps, and we've got non-inverting op amps. So these will all be useful when going through the lab. Also, you're going to want to look at the equations that you used in the passive circuits lab because they will also all be useful. Okay, so now I'm going to look at the manual a little bit and the answer template that we have. So here is the manual for Lab 3, and this is the overall circuit. So you can see we have 1, 2, 3, 4, 5, 6 total op amps in there. And some of them are inverting, some of them are voltage followers. It's an inverting op amp, and then if you look in the manual, we tell you how to find the gain for these two. So this is a filter, and the whole purpose of this circuit is to establish a nice stable reference voltage, which you do with the first op amp. We then use a voltage follower to prevent from loading that thermistor, so we don't change the voltage drop across it at all. We then boost our output to make it easier to measure. We have a filter to get rid of any 60 hertz noise from the AC lines that we're using to power this whole thing. And then we have a final inverting op amp to again boost it and bring us back to a positive voltage. Okay, so let's look at our answer document here. So we're essentially going to be looking for you to tell us what the voltage is at the output of each of these op amps. So we're telling you which figure to look at. So for example, for finding Vref, you're looking at figure 3.2. So I want to know what this voltage is going to be. Again, you're going to go through, and at each op amp, you should be able to calculate what the output voltage is going to be. So here, we're looking for an equation, and it's essentially going to be the equation you found in the last lab, but you're going to be rewriting what we're calling things, because this, what was the output before, is now in the middle of this circuit. So last time we had the voltage drop across the thermistor was just V out. Now we're calling it V therm. The input to this circuit is no longer VI, it's now Vref. Otherwise, the actual equation is going to be the same because everything else is the same. It's the same thermistor, so the same beta value, the same R naught, the same T naught, and we're using the same magnitude of resistor as R1. Again, we're looking for voltages at the output of each op amp, and then this will be the last op amp. It'll be the output of the whole circuit. So using either the voltages and V out over VI, or the resistances and what kind of circuit it is, I want you to calculate all of the ideal gains. And then also, we're giving you some voltages, and assuming that these were the numbers you measured, we want to know what measured gains that these numbers correspond to. So then at the end, using the ideal numbers, we want you to start with the output of the thermistor. So starting with V therm, we want to know what the gain is to the end of the circuit, to this V out. And then we want an equation where you can plug in this output of the whole circuit and know what temperature is. So you're going to have to do something with this equation you found earlier and replace V therm with the output of this whole circuit. And it's not going to be the equation that you found last time. It'll be very similar, but it will not be the exact same equation, because V out now includes all of this other part of the circuit. Whereas in the last lab, V out would have been the voltage right here. It is now the voltage here. And then using the V therm, or the V out that you found here, what temperature is that? So this shouldn't be a very difficult lab. Usually the hardest parts of this are actually building the circuit because it's got a fair number of elements, so it takes a while to do. And since you won't have to be doing that, it shouldn't take you too long to do just the calculations for everything. So once again, email us if you're having any trouble. You're going to be turning in just this answer template again. Make sure you put your name, your email, your section number. Make sure you convert it into a PDF before you turn it in. But you will just be turning in this answer template. So email if you have any questions, and otherwise, have a good week.